Good morning or good afternoon, everybody, and welcome to a episode that will be dealing with working with large models in Procon. And I'm actually thinking of creating a series on this where I'll be tackling some of the prevalent issues that we find when we work with extremely large models or just larger models in SUMO in general. Okay, so these can, I don't know, large would be a subjective term, I guess, but these are models that take over a minute, I would say a minute or a couple of minutes to analyze when you run them. Now, this of course is system dependent as well. But on my side, I have 64 gigs of RAM, I have a large CPU, and some of the models I've worked on take over 15 minutes at a time to analyze. And that's not even considering your second order and nonlinear analysis type. So I'll be going through some of the things that you can do to simplify your model, because that's really where it's at in having or just making this process as easy as possible for yourself, is really to simplify your model and get rid of unnecessary things that actually just bog down your model and make it difficult to run an analysis. So let's get straight into it. So I've got a SUMO model here. So this is not a large model on any scale, but this is a problem that I have come across actually from time to time. And the issue is with meshing. Now, if anything is going to weigh your model down, it is your plain shells, slabs, or wall meshes. Okay, these can add a serious amount of data to your model without even, you haven't even touched the analysis yet. And so in general, you want to get a sort of a sweet spot with your meshing, in that it's not too big, and at the same time that your mesh elements aren't so small that it actually just takes hours for you to analyze your model, because in the end you won't gain anything from that. You won't necessarily, there's a point at which you won't gain any more accuracy or significant accuracy out of your meshing. Okay, so here we've got a slab. So imagine this is now part of a large model, and we've got a cutout in the slab. This could be anything, because you've got an elevator shaft coming through there, or that this is just an opening in the slab for some reason. I think predominantly it would be because you've got an elevator shaft, or you've got stairs coming up through here, and you'll have large walls coming through here. Now, here, this edge is 200 mils wide. Okay, and this will severely affect, this will cause some serious problems with your meshing. So if we go to, let's say, our discretized model view, my slab mesh is set at 1 meter. And if I go to modify and I hit mesh all, you'll see that these little boxes here indicate that they are triangular elements. And it is very possible that once we run our analysis, that we are going to have some issues over here. All right, and you can see also it's not, in general, it's not a very neat mesh. So to work in there, to get this mesh to work accurately in here, you'll need a mesh that's probably smaller than or equal to that spacing over there. So let's try a mesh of 0.2. Let's run our mesh again. And you see that this is much neater, starting to look a lot better. But this will be incredibly heavy to analyze, especially on a large model. And remember that these slabs are probably connecting to other plane shells, to walls, and that if those elements can have the same size mesh, you also save a lot of time and a lot of effort in getting that right. Okay, so in this regard, what I would recommend, or in general, what I found to be quite a good mesh size that just helps, that's just convenient to work with, is 0.5. Okay, 0.5 mesh usually works quite well. What I'd recommend here is that we actually change this. We change the layout of the slab, and we add beams here that are the shape of this cutout, or this portion over here. So the slab is 330 millimeters thick. This is 200 mils wide. And what I would do then is I'd go to my level view, I'd modify, and I'm going to change. So I'm going to remove this cutout completely. I'm going to add lines from this column to that column to that column. Oops, sorry about that. Shouldn't have pressed cancel, should have just pressed exit or escape. Let me just switch these off. Saba, it's such a pain to snap I don't know why, but sometimes it is. Come on, there we go. Okay, then I'm going to trim these other edges away using the trim function. Okay, I'll go back to my main view, and this is now a slab. So what I'll do now is I'll go to sections and I'll load an equivalent section. So rectangular, so this was a those sections were 200 wide, 350 mils deep. There's a 200 by 330. And I'm going to add those as beams. Okay. So what you could also do then is, if you're concerned about what you've cut out, so just the 200 by 330 on that side, you can also add a beam there. Now, the only thing is here that it will create a bit of, it will make this section here much stiffer than what it actually is. So in that regard, you can add an additional point, area load to this, or whatever you feel like would be good. You don't have to trim back this section on this side over here at all. You can actually keep that little 200 lip there, just to make sure that you're not losing on any of the self weight. Or if that's not something that concerns you that much with just the self weight over here, then you can just proceed with this as is. Now if we mesh again, and you can see we don't have that problem of meshing this little section here. So even if you add that 200 lip over here that we just removed, it's not really a lip, just add that 200 mils to the slab. It won't cause any problems, which is really great. Okay, so I hope that helps. Just with how to think about openings in particular, to make that meshing as simple as possible, and so you don't run into funny errors when you're running your analysis. So alright, that's it for this particular episode of working on large models. The next episode I will also tackle if you have walls coming through your slab and so forth, and we'll tackle the meshing philosophy, or just your approach to meshing in that particular regard. We'll tackle that in the next video. Thank you so much for tuning in, and looking forward to seeing you in the future videos.